Earlier in the lesson, I was talking about the thread pool, and I thought I didn't explain it clearly. And this time, there's one more feature that the Copilot helps us with is you can select a part of the code and ask to explain. So this is very interesting feature that everybody can use it and learn about the code if we do not understand better. This generated code is complex. So knowing that feature of asking to explain will be very helpful. So I'm showing it here on the right hand side that we have the chat window, and here's the middle we have the text, the code. So the thread pool is the class, and this is a thread class. We have in the constructor there will be 4 threads created, and those threads are standing by. Those are worker threads, and in this code we have an important function called submit. Submit the task for the threads. So when we submit a task, and in submit, we have something called notify. I'll come back to that. This notify will notify one of the tasks, notify one. Then it will, one of the thread, that thread will be taking this task and execute. So worker threads are there standing by, and we submit a task with the help of submit call. Why submit? Why not just the function, that functions we provide? Here is why. We have submit, we want to have multiple functions getting called, add, greet, and print message, but they are of different data types, different return types, and input variables are different, and they do different things, and the number of parameters are different. So we have submit, we are calling for that pool submit function and giving add, greet, and there is a lambda function we are providing as well, and then submitting the print. Because of the variability, we need this function called submit. And I wanted the Copilot to explain what this submit does. It is a complex piece of code. Is hard for anybody to understand, even having knowledge about this. This is the a challenge with the generated code as well. These are very complex and sometimes very efficient code, but we need to understand before we use it in production. So I asked this to explain this code. Here is how I did. I select this, and once you select, you can right click on this on mouse and then Copilot, and you can say explain. There's explain option, explain the selected code, or you select it and then you here come there is no, it was used to be there. Anyway, so you can use this, right click the pop-up menu and select the Copilot, and Copilot explain. And there are other options also, generate document, test cases, and so on. So once I did that explain, here is on the right hand side, it is working on, I'm asking to explain this part of the code, and this is the explanation. And this submit is facilitating that we have a variable function. We have different functions with variable number of arguments that needs to be executed by the same fashion. by the threads. And here is what it does. The explanation is very clear. This submit function is a template method that allows you to submit any callable function, lambda, functor. Functor is a class we discussed in previous lessons, and anything callable that can be passed here with any number of arguments to the thread pool for asynchronous execution. It uses a perfect forwarding to efficiently pass the callable and its arguments, preserving their original types and value categories. Number of arguments and original types, they will be preserved. And here's a function explanation. This function first deduces the return type of the callable when invoked with the provided arguments with results of. Here is what it does. This is a function method, and it is a return type is future, is a trailing return type. This is the future, and with results of the arguments and taking that type, and this is what it will return. And also it is using a using keyword for that's what it says as deduce. First deduce the return type. Return type is deduced based on what we have in the argument, the result of argument and the type. So first we find that, and then the next is bind the arguments to the function. The function is f, and then the arguments are bound to the function this way with std bind call. So here is what it says. It uses std bind to bind arguments to the callable. Callable is a function or functor or lambda, creating a bound task that takes no parameters in this case. And this is the bound task is just the binding between function and the arguments. This bound task is wrapped in a std package task. So this is the package task that you took. You use a move function, call std move to put into a package task, which allows the result of the task to be retrieved via the std future. So this is a task created. This is a shared. It is also the package task is managed by a shared pointer to ensure its lifetime is managed correctly. Even if the task is moved between threads, we will see that task is moved. Here the task pointer is created for that bound task. The bound task is a binding between the function and the argument, variable function name and variable argument. And here is what it did. So it creates a future from that task pointer. It creates a future from the task pointer, and this future is returned. And now we have what? Inside the critical section protected by the mutex, the function checks if the thread pool is stopped and throws an exception if so. Otherwise, it adds new task to the queue, wrapping the package task in lambda that calls the package task when executed. This is talking about this part. we are having a lock guard for the queue, then if in in this stage, if all the threads receives a signal, you can say the stop is a Boolean flag. If this is accessible to all thread, and this should be here. Yeah, this is atomic. So if that is true, then you just return from there. You don't do anything further. Otherwise, you put that task pointer. We saw that task pointer into a lambda. uh, the dereference of the task pointer into the lambda. It says that otherwise it adds new task, dereferencing the task pointer and new task to the queue, wrapping with the package task in lambda. That this is a lambda, and inside that you put that package task, and then put it into the task that is your actual the member the queue where you put that. Mplace is the function, it will add to the task queue. This ensures all tasks in the queue have the uniform signature void return type. So because all functions that we saw, add, greet, they have different return types. So this is making uniform, and then it is this is just the printing of the information. And after that, after unlocking, it notifies the worker thread that task is available. So this condition is used, condition variable, to notify the task that this is ready, the task is ready, and it returned the future. So the task goes in the queue, the thread is returned. This is a condition variable, and condition variable. Once you say notify, because the task is waiting on that condition variable, and that's how this function is explained. Finally, the function returns the future to the caller, allowing them to retrieve the results of the task once it has been executed. Now, this future, this is where it has a return type, future, and from the task, getting the future, and then it's returning. So this submit is a uniform. It allows uniform execution of different function. We see here in the main submit, add, greet with different parameters and different return types. And there are four of the thread, four functions, four tasks are added to the pool so that the threads can execute. Here is some description, some print with the future get it to retrieve the results of those functions. That's what the future is. And here is more about that submit more task. And in a lambda, yeah, all are in lambda, 5 different tasks from 1 to 5, they are being created. And this is how we get the explanation of any part of the code that we don't understand. You can even select few lines. For example, I just had the definition before, and it explains in detail, even in depth. And it is also suggesting that in C++, for 11 and 14, it is used, this results of, but going forward from 17 onwards, it will be invoke result, and this is deprecated. All these informations are there with the LLM. and then it helps you correct your code in a better way. So here is what I would like to show you, that how we can ask this part of the code, entire part of this code. I want this to explain. Let's see what it does. Copilot explain. So in the chat window, it is explaining that part of the code. So just reading that, this code demonstrates how to use ThreadPool to submit various tasks of asynchronous execution and retrieve their results using future. That's what it is, future. The first few lines submit different types of tasks to the pool. A function add with two integers, function add with two integers, function greet with one string argument, lambda to compute the square of numbers after a short delay. There is a milliseconds delay, and it is just doubles the number square. And then excuse me, and a function print message, which can later be used to explain the results of the print message is likely return a void. So that's a void return type. Each call to submit returns a future that we saw, future, and which future object which can later be used to obtain the results of the corresponding task. So whatever results uh, provided by sub add, greet, and so on, then can be accessed here using that future. Okay, so after submitting the second section, after submitting the task, the code prints the message indicating that it is waiting for the results. It then calls get method, get of the future, of each future to block, which blocks until the task is complete and retrieves the result, if any. For example, for the print message task, which returns void, so calling get simply waits for the task to finish. This is the important part as well. This is the task submitted, and we need to call get so that we are waiting here. It will be a blocking call, so that once that is finished, then only it will return the result. The get method will return, and otherwise get simply waits for the call to finish. Okay. And the second part here, the third part, the vector, the code then demonstrates submitting multiple tasks in a loop. That's the loop, for loop, multiple tasks. And for each iteration, it submits a lambda that prints a message, sleeps for a short time, and returns a computed value. So here is a future, and in that it is waiting for it sleeps using the steady sleep for this std chrono milliseconds, and then it returns that value to the future. This is the lambda function, and the future for these tasks are stored in a vector that we see. This is a vector, allowing the program to later collect their results and wait for their completion. So here is that gate, and the next for loop, we are waiting for that future, that task to finish, and then we can get the result. And allowing the program later to collect the results or wait for the completion. When the return type is void, it will just wait. This pattern is typical for parallelizing independent tasks and efficiently utilizing multiple threads. So this is a very complex code about thread, and understanding these will give much more clarity about concurrency and parallelism happens in the code. Whichever programming language provides, this knowledge will be helpful. So this is C++, ThreadPool class is created. Let's go through that once again. We have certain member variable private. We have worker threads, thread object. Once we create object, the vector, and then we have task. Those are functions with void return type, void functions. And then we have mutual exclusion condition variable, atomic stop, that just to is atomic value so that all threads can use it to decide. Then cout mutex. Here is a worker thread, and this one will be running here. So in that thread, when it is running, when the task is submitted, as we discussed, this part will be executed, and then we saw the future, the return, it will wait there. Then, because those functions will be called from the task, the task is taking from the task queue. So we insert into the task in the main, in the submit function, we saw that submit and place. And in this worker thread, it will take that task here from the front is a queue. So it's taking from the front and popping that up, and it will execute that function here, task. It simplifies and simplifies in a way that any function, any data types, any return type of the function can be submitted here, and this task, this function call, will happen through this worker thread. And I hope this clarifies what we last in the last part of the lesson that we went through quickly, and this is the depth. And this tool, like Copilot, can be very handy and very friendly. You can ask anything and understand. So it explained very well any part of the code. For example, if I select this, I can ask, no, explain this, it will. And it will also create documentation. And that's about the thread pool, and I hope this should clarify a lot of things. It did for myself as well. When I went through this, it was not easy for me for the first time. So going through that again, if it's not clear, it will be very helpful. And after a couple of iterations, this will be easy for all programmers. And with that, and thank you. I will see you in the next lesson.